In this lab, we are going to take a look at OSPF Not-So-Stubby Area, the LSA Type 7 to Type 5 translation, the forward address, and also how we can inject a default route into the Not-So-Stubby area. So in this lab, we are going to turn area 2 into a Not-So-Stubby area and make router 4 an ASBR. So we are going to do redistribution on router 4 and advertise a few prefixes as external routes into OSPF. So let's do this first. On router 4, I have some prefixes on loopback 1, 2, and 3, which are not advertised into OSPF. To prove that, show IP protocols, only 4444, which is loopback 0, is advertised with OSPF. So let's redistribute these routes. So under the OSPF process, redistribute connected subnets. So now router 4 advertises these prefixes as Type-5 LSAs because we haven't configured area 2 as a not-so-stubby area yet. But let's take a look at the link state database. Show IP OSPF database, external self-originate, and as expected, router 4 advertises these prefixes as Type-5 LSAs. And one important thing to remember is that the forward address is set as 0000 in a regular Type-5 LSA. This means the advertising router, so router 4 in this case, the other routers which receive this LSA perform the SPF calculation towards router 4. For example, on router 7, show IP route 44, 44, 44, 44. So to reach this prefix, we have a forward metric of 4. This is the metric to the ASBR. So to router 4, in this topology, every link has a cost of 1 for simplicity. So 1 plus 1 plus 1 plus 1, which is 4. So the point is that we are performing the SPF calculation towards the ASBR. In a case of regular Type-5 LSA. This can be different if we do Type-7 to Type-5 translation. Now let's make area 2 a not-so-stubby area. We need to issue the same command on all of the 4 routers in area 2. So area to NSSA, and this will temporarily break the adjacency between the routers because the stop flag has to match in the hello packets. But after configuring the neighbor routers the same way, the adjacencies are established again. Here is a packet capture between router 4 and router 3. These are the flags in the hello packet if we turn area 2 into a not-so-stubby area. So the NSSA flag is set and the E flag, so the capability for external routing, is not set. This is because we won't be able to generate Type-5 LSAs. But in a case of a normal OSPF area, the NSSA flag is not set, of course, but the external routing flag is set to 1. So these flags has to match, of course, with the neighbor router to form the adjacency, besides many other things like the area ID, authentication hash, and many other things. So now on router 4, we are not allowed to create Type-5 LSAs. Show IP OSPF database, external self-originate. Now this is empty, but we create Type-7 LSAs instead. Show OSPF database NSSA self-originate, which are very similar to the Type-5 external LSAs. The forward address this time explicitly points to the ASBR, so to router 4, and we have this flag, which means that Type-7 to Type-5 translation is allowed on the ABRs. In the link state update message, this is the P bit, so the propagate bit. This is set by default, and this allows the ABR to convert this into a Type-5 external LSA and flood it across the whole OSPF domain. This is what we have already seen in one of my previous videos. The ABR is gonna convert the Type-7 LSA into a Type-5 LSA and injects it into the backbone area. But this time we have 2 ABRs. So the question is, which one will be converting the Type-7 LSAs? By default, only one ABR is elected as the Type-7 to Type-5 translator, which has to do the translation, and the other ABR does not generate Type-5 LSAs. And by default, the ABR with the higher router ID is elected as the Type-7 to Type-5 translator, which is in this case router 2. So let's check that. On router 1, show IP OSPF database external self-originate, we are not generating Type-5 LSAs on router 1, but router 2, show IP OSPF database external self-originate, router 2 does generate Type-5 LSAs. The advertising router is router 2, and the forward address is the router ID of the ASBR, so router 4. It is not the ABR. So the other routers still do the metric calculation towards router 4. We can change this behavior. Now let's make router 1, the other ABR, the Type-7 to 5 translator. So under the main OSPF process, the command is area to NSSA translate Type-7 and always. Now router 1 is the translator. On router 2, let's check the database, and the delete flag is set. So router 2 is not generating Type-5 LSAs anymore, but router 1 should be. So let's verify. Or show IP OSPF database external self-originate, and indeed, and look at the forward address. It still points to router 4, the ASBR. So for example, from router 7's perspective, the forwarding path is still the same as before. So it does the SPF calculation to router 4. Or let's run a trace route, for example, to 44, 44, 44, 44. And we take this lower path through router 2 because the lower path has less cost than the upper path. Now let's force the ABR to change the forwarding address to his own address in the Type-5 LSA. So the command is area to NSSA translate Type-7 always, and the keyword is suppress forwarding address. And if we take a look at the link state database, we can see that the forward address points to the ABR, so router 1. And if we do a trace route again from router 7, now it is different, because router 7 now does the SPF calculation towards router 1, not to router 4. So we take this upper path through router 5. And remember that, as I said, the propagate bit is set by default if we do the redistribution on the ASBR in the NSSA area, but we can simply turn it off. So redistribute connected subnets, and the keyword is NSSA only. Now in the LSDB, show IP OSPF database, NSSA external, self-originate, we have this flag, no Type-7 to 5 translation. This means that the ABRs are not allowed to generate Type-5 LSAs. Here is the link state update, and the propagate bit is not set this time. So now on router 7, for example, we can't reach this prefix anymore. So if I do a ping, and the ping simply fails. And I would like to talk about one more thing, the default route injection into the not-so-stubby area. In this topology, router 7 is also an ASBR, and it generates a single Type-5 LSA for this 77 prefix, which is just a loopback address which has been redistributed into the OSPF process. So by default, routers in the not-so-stubby area have no reachability to this route. So if I run show IPsef for this 77 prefix, and this prefix is simply not reachable. We don't have a matching entry in the routing table. This is because Type-5 LSAs are not allowed in the Not-So-Stubby area, and by default the ABRs don't generate default route into the NSSA. But we can do that, so let's inject the default route from router 1. So the command is area2 NSSA and default information originate, and this is very important. This is a Type-7 default route. So on router 4, for example, if we take a look at the routing table, the default route is an ON2 route, so NSSA external, which is Type-7. We can also verify this in the LSDB, OSPF database NSSA external, and here it is, and the advertising router is router 1. So now we can reach this 77 prefix through router 1. So let's run a trace route. Yes, so we take this upper path through router 1 because router 1 advertises the default route. And to reach other inter-area prefixes, for example the 7777 prefix on router 7, so to reach this prefix, which is an inter-area route, we still use router 2 as an exit point because of the lower cost. But we can also inject a type 3 default route into the Not-So-Stubby area. On router 2, the other ABR, under the OSPF process, if I say area 2 NSSA, no summary, this blocks all type 3 inter-area LSAs into the Not-So-Stubby area and injects a single type 3 default route. So on router 4, show IP OSPF database summary, and here it is, the default route, which is generated by router 2. And if we take a look at the routing table, or show IP route, we can see that the ON2 route has been replaced by the OIA route, because inter-area routes are preferred to external routes. So if I run a trace route again to this 77 prefix, which is again an external route, and now we use router 2 as an exit point. This is because the OIA route is preferred to the ON2 route. But as we can see that OIA, so inter-area routes, are still present in the routing table. This is because router 1 still generates type 3 LSAs into the Not-So-Stubby area. So if we issue the same command on router 1, so area 2 NSSA and no summary, so this makes area 2 totally Not-So-Stubby area. because we block type 3 LSAs on both ABRs. And on router 4, we have a single type 3 default route in the routing table, but both router 1 and router 2 generate a type 3 LSA. So show IP OSPF database summary. See, advertising router 1 and advertising router 2. So to reach external routes, we do ECMP because we have the same cost to both exit points. So to R1 and R2, and we have no visibility beyond the ABRs. So we can verify this on router 3. So show IP SAF this 77 prefix. So because of the ECMP, the traffic is load balanced among the two ABRs. So to summarize, remember that an inter-area route is always preferred to external routes. With the command NSSA default information originate, we inject a Type-7, so ON2 default route into the Not-So-Stubby area, and with the command NSSA no summary, we inject a Type-3 default route into the NSSA area, and also block every other Type-3 LSA.